everyone, I am Jillian Maracademia, a dedicated STEM student passionate about physics and eager to share some exciting concept with you. I will be your instructor for today. Starting with the scientific notation. Express the following in scientific notation. To express 1,230,000 in scientific notation, we write it as 1.23 times 10 raised to 6 because we move the decimal point 6 places to the left to represent the large number. For the number 00028, we will move the decimal point 4 places to the right to maintain the same value, and it will be written as 2.8 times 10 raised to negative 4. To represent 450,000, we will move the decimal point 5 places to the right, which will be written as 4.5 times 10 raised to 5. Moving on to the converting units. To convert 20 kilometers to meters, we will simply multiply 20 kilometers times 1,000 meters over 1 kilometer and cancel the same sign, and the answer would be 20,000 meters. To represent the large number, we will convert it into scientific notation. So we will move the decimal point 4 times to the left. So our final answer would be 2 times 10 raised to 4 meters. To convert 5 meters to centimeters, we will start with a given value of 5 meters times 1,000 centimeters over 1 meter and cancel the same sign, and it will be equal to 5,000 centimeters, and we will convert it into scientific notation. So we will move the decimal point 3 times to the left, and our answer would be 5 times 10 raised to 3 centimeter. Now let's convert 6 yard to feet. We will convert it by simply multiplying 6 yard times 3 feet over 1 yard and cancel the same sign, and our final answer would be 18 feet. Now let's move on to variance. Now let's answer this problem starting by getting the mean, and this is the formula for the mean. To calculate the mean, we will add up all the values, which are 8 hours, 7 hours, 9 hours, and 6 hours, and divide it to the sum of the total numbers of values, which is 4, and our total answer would be 7.5 hours. And now let's proceed to getting the variance. This is the formula for the variance. To calculate the variance, subtract the mean from each data point to get the differences and square these differences. Then divide it by the total number of values, which is 4. Then calculate it, and the answer would be 1.25 hours square. Now let's get its standard deviation, and this is the formula for standard deviation. On getting the standard deviation, we will just square the variance, which is 1.25 hours squared, and our answer would be 1.12 hours. Then we will round it, and it will become 1.1 hours. Our measured total time of their sleeping hours will be 7.5 hours with an uncertainty of 5.5 hours. Another example. Let's get the mean by adding all the given values, which are 9 cm, 10 cm, 8 cm, and 9 cm, and divide it by the sum of the total number of values, which is 5. The answer would be 8.8 centimeter. Now let's get the variance by subtracting the mean from each data point and square the result, then calculate the average of those squared differences and divide it by the sum of total number of values, which is 5. And our answer would be 0.56 centimeter square. And now let's move on getting the standard deviation. We will just square root the variance, which is 0.56 centimeter square, and calculate it, and it will become 0.75 centimeter, and we will round it, and it will become 0.7 centimeter. The calculated measured diameter of the pomelo would be 8.8 centimeter with an uncertainty of 0.7 centimeter. Let's have another example. Starting with getting the mean, let's add all the given values and divide it to the sum of values, which is 6, and calculate it, and our answer would be 170.67 centimeters. To find the variance, subtract the mean of each data point, square the results, then calculate the average of those squared differences and divide it to the total sum of the numbers, which is 6, and our answer would be 25.22 centimeters square. Now, let's square root the variance, which is 25.22 centimeters square, to get the standard deviation and calculate it, and it will become 5.02 centimeters, and we will round off it and it will become 5 centimeters. The measured circumference of the orange would be 170.67 centimeters with an uncertainty of 5 centimeters. Let's proceed in parallelogram method. Our first step will be writing the given. Now let's graph using the scale of 1 centimeter per 1 Newton. Let's plot letter A, which is 4 centimeter directed to north. Then plot letter B, which is 4 centimeter directed 40 degrees north of east. We will use protractor to determine the angle of 40 degrees. And now let's plot it. Then connect the endpoints of these lines with two more parallel lines, forming a complete parallelogram. Use the same measurement. Then draw a line in the middle. Then use ruler to determine the resultant and use protractor to determine the degrees of the angle. The resultant would be 6 Newton directed 60 degrees north of east. And now, let's have another example. We will again use the scale 1 centimeter equals 1 Newton. Let's now plot the first given, which is 6.0 Newton going south. And now we will plot the second given, which is 4.0 Newton directed 30 degrees south of east. We will use protractor to determine the angle of 30 degrees, then plot everything. Now, let's draw two parallel lines on every endpoints of the given to form a parallelogram. Then draw a line in the middle, then use a ruler to determine the resultant, which is the line in the middle, and use a protractor to determine the angle or degrees of the resultant. So our resultant would be 5.8 Newton directed 50 degrees south of east. Now, let's have another example. Let's start by plotting the first given, which is 3.0 meters square vertically, which means going to north. Then plot the second given, which is 3.0 meter per second directed 20 degrees north of east. We will use protractor to determine the degrees of the angle. Then draw two parallel lines on the endpoints of the given to form a parallelogram. Then draw a line in the middle to represent the resultant. Then use ruler to measure the resultant and use protractor to determine the degrees of the resultant. So our resultant would be 4.8 meter per second directed 56 degrees north of east. Let's proceed on polygon method. Let's now solve this sample problem. Let's start by plotting the given. Firstly, the 2.0 meter directed to east, then 2.0 meter directed to north, so we will plot it starting on the endpoint of the first given. Then plot the third given, which is 3.0 meter directed to west, and we will again start on the endpoint of the second given and draw a line on the starting point to the endpoint of all the three given, which will represent the resultant vector. Then use a ruler to measure the resultant vector and use a protractor to measure the angle of the resultant. So our resultant would be 2.4 meters directed 119 degrees north of west. Let's have another example. Let's start by plotting the given examples, which is 6.0 meter directed to north. Next is 4.0 meter directed to east. Then 3.0 meter directed to south. Then draw a line to the starting point and the end point of the given. Then use roller and protractor to measure and determine the angle of the resultant. And the resultant would be 50 meters directed 40 degrees north of east. Let's proceed to another example. Let's start by plotting the given, which is 4.0 meter directed to south, then 5.0 meter directed to east, then 3.0 meter directed south of west. Then let's draw a line to the starting point and the end point of the given to represent the resultant vector. And we will use a roller to measure the resultant and use a protractor to determine the degrees of the resultant. And our resultant would be 8 meters directed 69 degrees south of east. Let's proceed to our next topic, which is triangle method. Let's solve our first example, starting by graphing the given vectors. So our resultant and equilibrium will be 9.14 meters directed 59 degrees east of south. And now let's have another example. So our resultant and direction would be 5.8 meters directed 49 degrees south of west. And another example. So our resultant and direction would be 4.4 meters directed 67 degrees south of east. Let's proceed to our last topic, which is component method. Let's answer our first example, starting by computing the horizontal and vertical component of the vectors. Let's have another example. And last example. And that would end our topic.
I hope you found this tutorial informative, and if you have any questions
Or would like to explore more topics, feel free to reach out or explore our other lessons. Your feedback and engagement help us create better content for you.